scientists have confirmed something truly terrifying. All this time, 3I Atlas and N2 Sven were not simply passing through our solar system. They were collecting data quietly, methodically, and with a level of precision no natural object should possess. And now, for the first time, researchers have captured the exact moment when that information began transmitting back toward the region of space from which these objects originally arrived. The discovery was made by astrophysicist James Lowry, the first to isolate a clear, structured, coded signal emerging from N2 Sven. At first glance, the burst looked like an anomaly, an unusual spike on a frequency band that rarely shows activity. But as Lowry examined the waveform, the pattern resolved into something impossible to misinterpret. The signal carried encoding. It had layers, it had intervals, and most alarming of all, it was aimed directly outward, perfectly aligned with Sven's inbound trajectory, as if reporting back to its point of origin. Decoding attempts began immediately, and although scientists were unable to break the full structure of the message, they reached a unanimous conclusion almost instantly. A signal of this strength, periodicity, and complexity could not have been produced accidentally. No comet, no interstellar fragment, no natural process is capable of generating a transmission with coherent bandwidth distribution and stable coded segments. This was intentional, this was designed, and the most disturbing part is that the signal has not stopped. It is transmitting right now. As soon as the reality became clear, an emergency council of astrophysicists, cryptographers, orbital analysts, and senior scientific authorities was assembled. Meetings that usually require months of planning were convened in minutes. Their task was simple in description, but catastrophic in implication. Determine what information Atlas and Sven have gathered, understand how long the transmission has been active, and decide what measures must be taken before the data they are sending reaches whatever intelligence lies at the other end. The initial consensus is already forming, and it is anything but comforting. Atlas and Sven were not passive visitors. They were observers. They scanned our system, measured our fields, analysed our atmosphere, traced our radio noise, and studied our planet's defensibility. They behaved like reconnaissance systems, quiet, patient, and impossibly precise. And now that the transmission phase has begun, the only question that remains is what exactly they are sending, and who is meant to receive it. To understand that, we must examine what they measured, and why their movements, once dismissed as coincidence, were anything but accidental. Once the transmissions were confirmed, the next step was to understand what exactly 3I Atlas and N2 Sven had been collecting during their time within our solar system. And as researchers retraced the object's trajectories with fresh eyes, the picture that emerged was not one of passive movement, but of systematic surveillance. Every maneuver, every pause in acceleration, every adjustment previously dismissed as noise now aligned into a clear operational sequence. These objects did not simply pass through, they scanned. And they scanned with a level of precision that suggested intention, structure, and an underlying logic we had failed to recognize until it was too late. The first breakthrough came when analysts realized that both Atlas and Sven repeatedly positioned themselves near magnetic shear zones regions, where the solar wind splits unpredictably, revealing the deeper architecture of the heliospheric field. A natural object would have no reason to linger there. A reconnaissance system would. Mapping magnetic gradients is the first step in understanding a star's influence over its planets, the stability of interplanetary space, and the energetic environment of any technological civilization. Both objects crossed these zones with surgical accuracy, decelerating at the exact points where field measurements would be the most informative. Further analysis revealed a second pattern. Each object performed controlled adjustments when passing through the heliospheric current sheet, the vast, undulating boundary between solar magnetic polarities. In every known natural case, comets drift through this region without any sign of regulated behaviour. But Atlas and Sven changed thrust output, rotation rates, and orientation as though calibrating sensors. The data suggests they were sampling the sheet's structure, charting its stability, and evaluating how it interacts with planetary magnetospheres. Knowledge critical for understanding how well protected a system's inhabited world might be. Another disturbing finding was hidden in their light curves. During several inbound phases, both objects executed subtle orientation changes, that temporarily maximized their exposure to Earth-reflected electromagnetic noise. These adjustments coincided with periods in which atmospheric scattering peaks made it possible to gather detailed data about our ionosphere, radio traffic density, and the strength of artificial transmissions. In hindsight, the objects were acting like platforms conducting wideband reconnaissance of our technological footprint. And then there was the most troubling discovery of all. Both objects performed slow, sweeping passes through regions where Earth's protective layers cast long, faint signatures of atmospheric composition into space. These signatures are invisible to the human eye but detectable through multi-spectrum scanning. Atlas and Sven collected readings consistent with high-altitude chemical mapping, precise enough to build a detailed model of our climate, our biosphere, and the structural weaknesses in our atmospheric shield. These passes were not randomly aligned. They were timed. They were optimized. They were repeated from multiple angles, just as a surveillance drone would refine a scan by covering the same target from several perspectives before compiling the results into a final dataset. The deeper the scientists examined these patterns, the clearer the conclusion became. Atlas and Sven were conducting a full-spectrum reconnaissance mission of the solar system. They analyzed solar fields, planetary defenses, electromagnetic emissions, atmospheric consistency, radio traffic, heat signatures, orbital debris, and magnetic distortions. Everything they did, every pause, every rotation, every anomaly, fit perfectly within the behavior set of an observing system collecting strategic information. By the time the researchers realized this, the transmissions had already begun, and what they were sending was not random noise. It was organized. It was structured. It was the product of everything they had quietly gathered while we mistook them for cosmic debris. And this leads to the next critical question, one that forced the Scientific Council to re-examine the impossible coincidence everyone had ignored. Why did two separate interstellar objects behave like synchronized instruments, operating as if they belonged to the same program? What unsettled the Scientific Council even more than the transmissions themselves was the realization that Atlas and Sven were not acting independently. Their trajectories, once analyzed without preconceived assumptions, began to reveal a startling level of synchronization patterns too consistent and too deliberate to be dismissed as coincidence. Though they entered our solar system years apart from different angles and at different velocities, their behavior aligned with a precision that defies all natural expectation. It was as if both objects were following the same playbook, executing different sections of a shared program with unnerving coordination. When orbital dynamicists reconstructed their paths in detail, the first symmetry emerged in the timing of their non-gravitational accelerations. Every thrust adjustment Atlas executed had an analogue in Sven's behavior, offset not randomly, but proportionally by the difference in their arrival times. The objects responded to the same heliospheric features in the same way, slowing in identical magnetic drift corridors, reorienting at matching angular thresholds, stabilizing their spin when passing through solar resonance zones. These were not accidental correspondences. These were operational signatures from systems designed to behave identically under identical conditions. More alarming still was how both objects compensated for solar torque. Natural bodies tumble when subjected to rotational stress, but Atlas and Sven executed nearly identical corrections, as though adhering to a shared stabilization algorithm. Their rotation axis adjustments matched in frequency ratios, in amplitude damping, even in the thermal consequences that followed. No two comets ever behave like this. No natural debris responds with mirrored precision to chaotic solar forces. Yet these two objects did, mirroring each other across years and millions of kilometers, like two components designed to remain synchronized no matter how far apart they drifted. Then researchers examined the patterns in their scanning behavior, and the parallels became impossible to ignore. Sven mapped the heliospheric current sheet along a wide arc, while Atlas performed a tightening spiral through the same structural layers years later. Sven executed broad-spectrum electromagnetic sweeps. Atlas repeated the same sweeps at a narrower spectral range, consistent with a high-resolution follow-up scan. Sven collected large-scale gravitational field irregularities. Atlas traced microgradients across those same anomalies with surgical precision. It was a two-stage reconnaissance profile, one object conducting the initial wide survey, the other refining the data. This mode of operation is not something nature produces, it is something designed. As cryptographers studied the outbound transmissions, they found yet another symmetry. The modulation patterns in Atlas's signal contained harmonic gaps that matched harmonic peaks in Sven's emission. It was as though each object carried part of the same dataset, with the full information only reconstructible when both signals reached their destination. One transmission was broad, the other narrow. One was structural, the other analytical. One encoded large-scale environmental layout, the other encoded detailed measurements. A natural explanation cannot account for complementary encoding in two unrelated interstellar bodies, but a coordinated reconnaissance network can. The timing of the transmissions was the final confirmation. Sven's bursts began precisely when Atlas reached the end of its inbound trajectory, two sequences separated by years, yet synchronized perfectly when corrected for distance, speed, and light travel delay. The objects were not responding to each other, they were completing phases of the same mission. Their combined data streams formed a unified pattern directed toward the same distant region of space, a singular origin point, the place neither object ever deviated from in its outbound communication. That was the moment the Council stopped speaking in terms of individual anomalies. The language shifted. Not Atlas did this, and Sven did that, but the system behaved this way. Because Atlas and Sven were not two coincidences, they were two devices. And now that the pattern of synchronization is understood, one question emerges with terrifying clarity. What exactly did they transmit together? To answer that, we must examine the structure of the signals and understand the moment when both objects entered the phase of active data return. The moment the Scientific Council understood that Atlas and Sven were operating as a synchronized system, the next logical step was to identify the exact instant when their mission transitioned from passive observation to active data transmission, and as soon as the temporal signatures were aligned and the spectrograms cleaned of solar interference, the truth revealed itself with such stark clarity that even the most conservative analysts could not deny its implications. The first transmission spike came from Sven, a narrow band beam, coherent far beyond any natural emission, rising from near background levels to a structured, pulsed architecture that carried both amplitude modulation and frequency stepping, as if packaging different classes of information into layered envelopes. Its directionality alone was enough to uproot every natural interpretation, because the signal did not diffuse outward like thermal noise or plasma scattering. It surged along a perfectly straight vector, a needle of encoded information aimed directly at the same deep space coordinates from which Sven had originally approached, as though the object were reporting back to its origin with unwavering accuracy. Minutes after this pulse, Atlas released its own emission, weaker but mathematically synchronized, matching the same outbound direction after adjusting for their positions in space. This dual transmission event was not merely coincidence, it was the operational handoff of stored reconnaissance data, unfolding in a sequence that mirrored the logic of two machines completing their assigned roles. What horrified the researchers was not simply the existence of the signals, but the complexity hidden within them. Each burst contained harmonic subchannels that revealed segmentation, structural signatures consistent with environmental mapping, repeating intervals that suggested compression blocks, faint, rapidly oscillating segments that hinted at high-resolution data streams. Spectral analysis showed that these transmissions were not leaking or drifting. They were controlled, stable, and deliberately constrained within narrow tolerances, characteristics never observed in natural objects, and extraordinarily difficult to produce even with human technology. The power levels were equally alarming, strong enough to survive attenuation across interstellar distances, yet modulated with such precision that not a single cycle appeared wasted. The efficiency was unnatural, the structure was intentional, and the consistency was the most frightening part, because the signals repeated in perfect alignment with the object's rotational minima, as though each device was timing its transmission to present an optimal antenna-like surface to the void at the moment of emission. When the Council overlaid the timing of the data burst with the object's historical maneuvers, the pattern deepened further. Every region where Atlas or Sven had executed a deliberate non-gravitational adjustment corresponded to a category of data likely included in the transmission: magnetic shear zones, heliospheric current sheet crossings, Earth-facing illumination peaks, gravitational drift corridors, and atmospheric signature angles. it became clear that the objects were not simply scanning randomly. They were collecting data in predefined packages, each type of measurement stored until the transmission phase began, then distributed between the two outbound signals like a pair of coordinated data relays. Sven transmitted the broad environmental architecture of the heliosphere, while Atlas appeared responsible for the localized high-resolution refinements, Earth-specific reflections, atmospheric composition gradients, radio frequency noise profiles, and possibly even technological emissions. Together, their transmissions formed a parallel data output system, each object handling part of the workload, each completing a section of the same mission. Further analysis revealed that the energy curves of both signals dipped sharply after each major burst, as though the objects were drawing from stored reserves, rather than relying on passive thermal excitation. This drop was not chaotic. It followed a predictable recovery pattern, suggesting that both Atlas and Sven possessed internal systems designed to accumulate energy slowly and release it only at key transmission intervals. The recovery curves themselves matched too closely across both objects to be natural. The symmetry was algorithmic, the timing mechanical, and the energy expenditure charted with the kind of precise resource management that characterizes engineered systems, not country nuclei. Even more troubling was the repeated discovery of subharmonic distortions within the signals, distortions that behaved like checksum markers, as though each transmission included internal verification to ensure that the data arrived uncorrupted at its destination. This concept exists in human technology, but has never been observed in natural astrophysical signals. By the time these confirmations were assembled, one collective thought permeated every discussion, though no one wanted to be the first to articulate it. The objects were not sending random information. They were sending a report encoded, structured, optimized, and dispatched with purpose, one that contained a complete multi-angle scan of our solar system, and more importantly, a comprehensive assessment of Earth itself. The realization that the transmission phase was not a brief event but an ongoing process, still unfolding with quiet regularity, forced the Council to confront the full magnitude of what was happening. These signals were not isolated anomalies. They were the final stage of a mission that had been underway for years, perhaps decades. And now the data they gathered was no longer in our hands. And so the question no one wanted to ask became impossible to avoid. If all of this information, our fields, our atmosphere, our orbital stability, our electromagnetic profile, our technological emissions, is being transmitted to the same distant point in space, then who or what is on the receiving end of these reports? And what will it mean for us when that receiving entity finally processes the data that Atlas and Sven have worked so methodically to gather? As soon as the Council began reconstructing the likely contents of the transmissions, the sheer scale of the object's observational capabilities became apparent, revealing a profile of surveillance far beyond anything humanity had ever envisioned being carried out upon us. Their flight paths, once plotted against every environmental, electromagnetic, and gravitational structure within our system, formed a map of deliberate interception, each maneuver corresponding to a type of measurement that fit neatly into the architecture of a full-spectrum reconnaissance dataset. The first layer of their report likely contained heliospheric topology, the broad, sweeping structure of the magnetic field surrounding our star, charted through their precise movements across regions where solar wind patterns diverge. This would provide any receiving intelligence with a complete model of how energy flows through our system, information essential for navigating or manipulating the space we inhabit. The next category of data, inferred from the synchronized pauses and reorientations near the heliospheric current sheet, would include the polarity transitions of the solar magnetic field, capturing its cycle phase and structural integrity. This alone would allow an external observer to forecast long-term solar stability and identify vulnerabilities in the solar environment that might affect planetary climates, communications, or power systems. Atlas and Sven did not drift lazily across this boundary. They inserted themselves repeatedly into its folds, slowing at the very moments when field measurements would be clearest, like systems designed to analyze the electromagnetic heartbeat of our star. The third and most disturbing portion of the reconstructed report concerns Earth. Every time the objects crossed regions where reflected electromagnetic emissions from our planet were strongest, their behavior changed in measurable intentional ways. The slight reorientation of their rotational axes during these windows suggests they were gathering wide-band reflections of Earth's ionosphere, extracting data on atmospheric density, chemical layers, and the thermal imprint of human civilization. From these patterns, an external intelligence could model our climate, detect cities by their heat signatures, evaluate greenhouse gas concentration, and even infer technological advancement by analysing the patterns of radio leakage escaping into space. Atmospheric spectroscopy such as this cannot occur by accident. Both objects adjusted their attitude exactly when Earth's spectrum provided the clearest view of our environmental state. Beyond environmental data, the objects also sampled our magnetic defences. When Atlas passed through the magnetotail several years ago, its rotational velocity decreased briefly, allowing it to linger long enough for its coma-facing geometry to absorb the extended plasma flux generated by Earth's field interaction with the solar wind. Such behaviour indicates purposeful mapping of the boundary layers that protect our world from high-energy particles. Sven repeated this action from a different angle, capturing three-dimensional magnetic variations that only become visible when observed from staggered positions. Together, their combined data would reveal the geometric weaknesses in our protective layers, information that could be invaluable for determining how resistant Earth is to external electromagnetic manipulation. Even more alarming were the passes in which both objects aligned themselves with Earth's radio-facing side during periods of dense communication traffic. Their light curves exhibited subtle fluctuations synchronized with peaks in terrestrial technological emissions. Satellite uplinks, military radar sweeps, atmospheric re-entry signatures, and even the faint scattering produced by terrestrial power grids. These patterns allowed the scientists on the Council to infer the darkest truth of all. Atlas and Sven were gathering intelligence on our technological infrastructure, its density, its coherence, its fragility. This included not only civilian systems, but the global distribution of electromagnetic noise associated with advanced defense networks, the kind of scanning one would conduct to determine whether a planet is capable of monitoring or repelling deep space threats. The objects also traced orbital debris fields, maneuvering with slight course corrections when passing through regions where human-made fragments drift. This behaviour indicated that they were measuring the density of objects we place into orbit, a direct indicator of our industrial reach beyond the surface. A civilization that launches satellites produces debris. A civilization that cannot launch anything leaves a sterile sky. The objects knew the difference. Putting all of this together, the Council realised the magnitude of what had been sent outward. It was nothing less than a complete reconnaissance package, a structural blueprint of the heliosphere, a detailed map of Earth's magnetic and atmospheric layers, a snapshot of our global power distribution, an evaluation of our electromagnetic noise profile, a measurement of orbital activity, and perhaps most troubling of all, a thermal portrait of our civilization, its patterns, its density, its vulnerabilities. If such data were indeed transmitted to their origin point, then whoever or whatever resides there now possesses a level of insight into our planetary environment that no human adversary has ever attained, insight that could be used to predict our reactions, identify our weaknesses, and exploit the very fabric of our defences. The realisation that these objects were not simply observing but evaluating struck the Council with a chilling clarity. This was not a survey performed for curiosity. It was an audit, a structured, methodical assessment of a world and its inhabitants, and now that the data has left our solar system, the only question remaining is what conclusions were drawn from the report and how those conclusions will shape whatever comes next. But before we can address that, we must confront the deeper implication. If Atlas and Sven collected and transmitted such an enormous body of intelligence, then we must understand why they were allowed to operate without interference and why their mission continued unnoticed for so long. Because the answer to that question reveals the final and most unsettling truth of all. By the time the Scientific Council finished reconstructing the likely contents of the transmissions, an even darker realization had begun to take shape. A realization that forced every expert involved to confront the very possibility they had been avoiding since the first coded burst appeared. Atlas and Sven were not anomalies, not wanderers, not cosmic relics drifting by chance into our region of space. They were operators. They carried out a mission with a precision that left no room for misinterpretation. They arrived silently, gathered data meticulously, transmitted their findings with unwavering efficiency, and departed our system in the same cold, structured manner in which they entered it. And as their signals continued to pulse outward into deep space, repetitive, disciplined, and unmistakably intentional, the truth became painfully clear. While we had been studying them, they had been studying us with far greater depth, clarity, and purpose. Their silence was not benign, it was calculated. The most disturbing element of the final analysis was not the breadth of information they acquired, but the realization that our ability to detect their behavior came only at the end of their mission, long after the majority of their observations had already been completed. Their flight paths were designed to appear chaotic to casual observers, hiding the systematic structure of their reconnaissance behind the statistical noise of natural cometary motion. Every maneuver they performed was optimized to blend into gravitational uncertainty. Every pause in acceleration masked itself beneath expected variations. Their scanning methods, magnetic sampling, spectral reflection, atmospheric analysis, radio pattern collection, were embedded within movements subtle enough to escape detection until the exact moment they chose to reveal themselves through transmission. They were not simply efficient, they were stealthy. This stealth extended to how they approached Earth itself. While our instruments were focused on conventional cometary markers, Atlas and Sven oriented themselves in ways optimized for absorbing Earth's outgoing signals, capturing the faint leakage of our communication networks, the whisper-level scatter of our radar sweeps, the power signatures of our orbiting satellites, and the thermal glow of our cities bleeding upward through the atmosphere. They measured the stability of our magnetosphere, the resilience of our ionospheric shield, and the density of our orbital infrastructure, constructing a portrait of Earth's defensive posture, not from what we intentionally broadcast, but from what we could not help but reveal. Their reconnaissance was not superficial, it was exhaustive. And now that this reconnaissance has been sent away, the final fear emerges naturally from the data. The transmission was not simply the end of a mission, it was the beginning of a response cycle. There is no scenario in which such a detailed scan is performed purely for curiosity, no logical model in which an intelligence deploys two synchronized probes across interstellar distance without expectation of receiving the information and acting on it. The objects behaved exactly as one would expect from a reconnaissance network sent to evaluate the viability, defensibility, and developmental maturity of a planetary environment. They acted not as explorers, but as auditors, measuring not merely what exists, but how it behaves under external observation. The Council's internal reports now reflect a sobering consensus. The question is not whether Atlas and Sven completed their task, but how long ago the majority of their report reached its destination. Even at the speed of light, the delay between their outbound signal and any potential response is measured not in comfortingly vast timescales, but in intervals short enough to matter. Their transmissions did not dissipate. They remained coherent long after they left our monitoring range. And coherence implies intent, not only to send, but for someone to receive clearly. It is in this understanding that the final and most chilling conclusion emerges. For the first time in human history, we are forced to consider that our solar system may have been the subject of an external assessment, a structured multi-phase evaluation carried out by systems whose origins remain unknown. And now the data they gathered is no longer here. It is elsewhere, in the possession of whatever intelligence deployed them, whatever entity built them, whatever civilization deemed it necessary to understand our world from the shadows of deep space. The point of these transmissions was not to warn us, not to communicate with us, and not to announce their presence. They never intended to speak to humanity. They intended to speak about us. The Council's final notes do not offer predictions, reassurances, or conclusions. They offer only a statement of fact, delivered with the kind of measured dread that comes from understanding too little, too late. The observers have finished observing, their report has been sent, and whatever happens next will no longer be defined by what we know, but by what they know about us. And as the last traces of their encoded signals fade into the dark between stars, the scientists who witnessed them can only accept the truth that hangs over every quiet laboratory and sealed briefing room. During all these years, we believed we were alone because nothing answered. Now we understand, nothing answered because nothing needed to. They were already listening. In the final hours of analysis, when the last fragments of data from Atlas and Sven were arranged into a single unbroken chain of evidence, the Scientific Council was forced to confront the one truth that no one dared articulate aloud throughout the entire investigation. Nothing in this sequence was accidental. Nothing in their trajectories, their pauses, their maneuvers, their coordinated patterns, or their transmissions reflected the randomness of natural bodies. Instead, every detail formed a closed system of actions so densely interconnected that the mission could be reconstructed backward, its phases, its objectives, its logic, like a blueprint hidden within the mathematics of their movement. And as the Council deciphered this blueprint, the realization arrived with a weight so absolute that it stripped the room of any remaining doubt. The reconnaissance cycle has concluded. The timing of their departure was perhaps the most telling detail of all. Atlas and Sven did not fade into the void at random moments dictated by gravitational drift. They left when their final data bursts aligned perfectly with regions of low solar interference, ensuring maximum clarity and minimal loss across interstellar distance. Their exit vectors were not chaotic but optimal, chosen to preserve the structural integrity of their transmissions as they travelled into deep space. Both objects accelerated slightly, the kind of subtle non-gravitational impulse that had baffled researchers for years, confirming that even their departure adhered to the same algorithmic precision that defined their arrival. It was the quiet closing of a mission, not a retreat, not an escape, but a scheduled completion. What became clear in those final reconstructions was that Earth had been evaluated with a level of scrutiny it had never before experienced. Every defensive layer, magnetosphere, ionosphere, atmospheric chemistry was scanned. Every technological footprint from satellite constellations to surface-based radio patterns was catalogued. Every thermal emission and electromagnetic rhythm produced by human civilization was absorbed and encoded. The probes gathered not only information about what Earth is, but about what Earth can do, how it behaves, how it stabilizes itself, and how easily its environmental and technological systems can be disrupted. This was not curiosity. This was classification, and now that the intelligence they collected has left our system, we must confront the consequence that no transmission can be recalled, no dataset can be intercepted mid-flight, no information can be undone. The report exists. It is travelling, and somewhere, perhaps closer than we imagine, perhaps unimaginably distant, there is an endpoint where that report will arrive. The Council cannot determine when it will be received or by whom. But they know one truth with certainty. Whoever sent Atlas and Sven designed them to endure the journey and deliver the data intact. In the aftermath of these revelations, the scientific institutions that once dismissed the earliest anomalies now confront the enormity of their mistake. Silence, delay, and misplaced caution allowed the probes to operate unchallenged, their scans unnoticed, their mission uninterrupted. The realization that humanity played no role in detecting or understanding the mission until its final phase weighs heavily on every participant of the Emergency Council. Because now, as the last echoes of the transmissions fade into unreachable distance, we are forced to admit that our ignorance was never the barrier. Our assumptions were, and so the Earth faces a new kind of uncertainty, one not born from speculation but from physics, because in a universe governed by information, the moment data leaves your hands, control leaves with it. The probes have finished their task, the report is in transit, the evaluation is complete, the next move no longer belongs to us. Whether silence follows or an answer or something far worse is a question no calculation can yet solve. But the scientists who witnessed the final alignment of the transmissions agree on one thing, expressed quietly, almost reluctantly, in the closing line of the Council's sealed briefing. Observation is never the final phase, it is only the beginning of whatever follows. In the hours that followed the final confirmation of outbound transmissions, the tone within the Scientific Council shifted from analytic tension to a deeper, more suffocating awareness, an understanding that the data already sent was not the end of an event, but the beginning of a timeline that now extended beyond our solar system and beyond our control. Every model reconstructed by the analysts showed the same unsettling fact. The probes had not only gathered environmental and technological information, but had done so with a consistency suggesting that these datasets were intended to be evaluated in relation to something far more specific than simple cataloguing. The structure of the transmissions, the segmentation of the data, the categories of the measurements, and the complementary way in which Atlas and Sven distributed observational tasks all pointed to a singular, unavoidable conclusion. Earth was not merely observed, Earth was assessed, and the assessment was carried out with a precision that implied criteria, standards, and thresholds. The probes did not only study who we are, they studied what we are capable of, what we can detect, what we can resist, and how quickly we can respond to unexpected stimuli. Every magnetic pulse, every modulation shift, every pause in their maneuvers aligned with moments that tested the limits of our monitoring systems, as though the probes were deliberately watching how efficiently and how aggressively we guarded our own space. Their path through the magnetotail, their proximity to orbital debris clusters, their exposure to high-traffic radio windows, all of it mapped not only our environment, but our vigilance. And now that this data is travelling outward, encoded and immutable, the scientists who reviewed these patterns can no longer avoid the idea that what awaits on the receiving end is not casual curiosity, but a structured intelligence evaluating whether Earth is a defended world, a vulnerable world, or something in between. The implications of this perspective ripple outward into every interpretation of the mission, because reconnaissance of this depth does not exist in isolation. It is always followed by classification, and classification is always followed by decision. Whether that decision is observational, diplomatic, strategic, or hostile lies beyond any model we can construct. But the logic remains unchanged. You do not map the defences of a world unless you have a reason to consider what might come after understanding them. And so, as the Council closed its final session and sealed the last report, a single unspoken truth lingered in the air with the weight of something inevitable. The transmission was not the last step of their mission. It was the first step of whatever mission follows. The probes have left. The data is gone. And now, for the first time in human history, the next phase no longer unfolds here, but somewhere far beyond the reach of our instruments, in the place that sent them, where someone or something is now studying us as meticulously as their machines once studied our world. Whatever judgment follows will not be shaped by what we wish to believe, but by the portrait they have already drawn. And as the scientists confronted this quiet, crushing realization, the weight of what had already taken place began to crystallize into something far more disturbing than any single anomaly, maneuver, or signal they had catalogued, because the conclusion they now faced was not merely that an external intelligence had observed Earth, but that it had evaluated Earth according to a framework we are not yet sophisticated enough to fully comprehend. What troubled the Council most was the way every detail of the probe's behaviour, every pause, every rotation, every shift in emission, every carefully timed measurement fit seamlessly into a pattern that implied the presence of criteria we had not even known existed. It was not the volume of data they collected, but the intentional structure behind the collection that suggested the assessment was conducted with benchmarks, thresholds, perhaps even expectations, like a test administered without the subject's knowledge. Because if Earth was evaluated, then the evaluation had an objective. And if the evaluation had an objective, then its result, whatever it may be, was destined to inform a decision made far beyond our world, in a place where our arguments, fears, or denials mean nothing. The Council's internal documentation shows that the deeper they reconstructed the probe's mission, the more the pattern resembled a tiered assessment of planetary resilience, as though the probes were categorizing Earth not simply by environmental metrics, but by strategic viability. Their traversal of the magnetotail was not random. It mapped the elasticity of our magnetic shield and its behavior under varying solar stress conditions. Their sampling of atmospheric layers was not limited to chemistry. It captured the dissipation rates of heat signatures and the presence of artificially produced compounds that betray industrial activity. Their sweeping passes through orbital debris fields were not marvelling at human achievement. They were analysing the density and frequency of human-made objects in low orbit to determine whether Earth has begun the transition into a spacefaring, defence-capable civilization. Every gesture that once seemed benign revealed, under closer inspection, an underlying logic. Probing for thresholds humans had inadvertently broadcast through the behaviour of their own systems, and what startled the Council even more was how the probe seemed to examine the limits of Earth's alertness. They approached radar shadow zones during calibration windows, as though testing our blind spots. They shifted their scanning patterns during periods of ionospheric turbulence, measuring how effectively our detection networks compensated for natural interference. They introduced faint, nearly undetectable anomalies into background radiation bands, then adjusted their orientation to observe whether Earth systems flagged them. These actions painted a picture far more unsettling than simple reconnaissance. They suggested the probes were not only observing what Earth is, but how Earth notices, how Earth reacts, and how Earth prioritizes anomalies. They were studying our awareness, not merely our environment. The analysts tasked with reconstructing the purpose behind these behaviors began to see a second pattern, one that resembled a stress test. The probes performed actions analogous to controlled provocations, subtle pushes against the edges of our perception to determine whether Earth possessed the capability to detect or interpret them. When a gravitational microperturbation occurred during a solar storm, Sven repeated an almost identical disturbance hours later during calm conditions, correlating its behavior with the differential in Earth's monitoring response. Likewise, Atlas released faint microwave fluctuations in bands known to be monitored by early warning systems, then repeated those emissions days later in quieter ranges, mapping our sensitivity curve with extraordinary precision. It was as though they were taking the measure of a century, learning how quickly the guard turns his head, how deeply he sleeps, how sharp his vision becomes in darkness. And now that the data has left our solar system, encoded meticulously within tightly structured transmissions, the Council can no longer deny the implication that Earth was not just observed, Earth was audited. The probes did not behave as scientists collecting knowledge. They behaved as instruments evaluating capability. They catalogued our strengths, our defences, our blind spots, our delays, our vulnerabilities, and our stability under strained environmental conditions. They learned how we monitor the skies, how our instruments behave under pressure, how our scientific community communicates anomalies, and how slowly or quickly global institutions respond to emerging threats. They learned not just what Earth is, but how Earth behaves when watched. This realization forced the Council to confront the final, most chilling inference of all. If the probe's mission truly followed a structured sequence of reconnaissance, classification, and transmission, then the phase we witnessed. The departure of the probes and the outward-bound encoded signals marks not a conclusion, but a transition. The data is now in the hands of the intelligence that deployed them, and whatever purpose the probes served, whatever assessment they performed, whatever thresholds they measured, that information is now being analysed elsewhere, far beyond the limits of human reach. The Council members understood that this was no longer an academic exercise or a scientific curiosity. It was the beginning of a timeline in which Earth is no longer an anonymous speck drifting unnoticed through the void, but a surveyed, catalogued and quantified entity in the archives of a civilization whose intentions remain completely unknown. The silence that followed the Council's final session was not the silence of relief or resolution, but the silence of recognition. The recognition that Earth now exists in a context humans have never before occupied. We are no longer unobserved, we are no longer unmeasured. The probes have departed, their report is en route, and the next chapter in this sequence will not unfold here but wherever those signals terminate. And whether that next step is peaceful, indifferent, or catastrophic lies beyond every chart, every model, every projection the Council attempted to construct. Because the truth they were forced to accept is that once data leaves your world, the reaction to that data becomes someone else's decision. The moment the Council accepted that Earth had been evaluated according to criteria far beyond our scientific framework, the next inevitable step was to attempt the one task they were least prepared for, modelling the potential consequences of that evaluation. This was not an academic exercise conducted in the comfort of speculation, but a calculated effort to understand what it means for a world to be scanned, measured and classified by instruments that behave with the precision of reconnaissance technology. The analysts began by reconstructing the probe's data priorities, ranking them according to the frequency of measurement and the energy invested in each observational phase. From this lattice of behaviour, a disturbing pattern emerged. Atlas and Sven devoted disproportionate attention to metrics directly related to strategic assessment: defensive field stability, technological density, atmospheric penetration thresholds, electromagnetic camouflage, thermal leakage, and response inertia. These categories correspond not to environmental curiosity, but to the assessment of a planet's capacity to resist, detect, or withstand external interference. and once the researchers mapped these priorities against known frameworks of military, exploratory, and reconnaissance behavior, human or hypothetical, they were forced to admit that the probe's mission aligned most closely with protocols designed to evaluate potential targets, vulnerabilities, or corridors of approach, as though identifying the weak points of a system whose defender may not know it is being evaluated. From this realization came the Council's first attempt to generate a classified sequence of likely scenarios, each one built upon the assumption that the intelligence receiving the probe's data will make decisions based on empirical assessment rather than on curiosity or philosophical interest. The first scenario, considered the least catastrophic but still deeply unsettling, suggests that Earth's presence has now been confirmed by an external civilization that may choose to observe further without immediate action, treating our planet as a developing entity not yet significant enough to engage. This scenario, though mild in comparison, carries the implicit warning that Earth will no longer be ignored. The probe's return transmissions ensure that humanity is now on a map we never wanted to appear on. The second scenario, far more complex, envisions a follow-up reconnaissance mission, one designed not to gather baseline environmental data, but to test specific vulnerabilities outlined in the probe's report, such as the stability of our ionospheric shield under targeted electromagnetic interference, or the resilience of our orbital infrastructure under simulated disruption. This scenario treats the first mission as phase 1 of a multi-stage evaluation sequence, where future probes would behave more aggressively still silently, still without communication, but with maneuvers intended to provoke specific responses and measure our adaptability. The third scenario, which the Council discussed with visible discomfort, speculates that the intelligence which deployed Atlas and Sven may not rely on biological or diplomatic frameworks at all, but on automated decision trees, meaning that Earth's classification has already triggered a predetermined outcome. In such a case, the probe's report does not inspire curiosity or deliberation, but initiates a chain reaction similar to how humans evaluate planets through automated systems, determine atmosphere, determine resources, determine defensibility, determine strategic value, and then categorize the world accordingly. If Earth falls into a category associated with low technological maturity and low defensive capability, the response could be one of opportunistic exploitation, automated visitation, or resource assessment. If Earth falls into a category associated with moderate resistance capability but incomplete space infrastructure, the response could favor long-term surveillance. And if the probes identified Earth as volatile, unstable, or dangerous, the response might include precautionary distance or automated preemptive safeguards. None of these outcomes are comforting. All are grounded in the patterns of the probe's mission. But the fourth scenario was the one that silenced the room completely, not because it was the most dramatic, but because it was the most mathematically plausible. This scenario suggests that the probe's evaluation of Earth's defenses, technology, awareness, and vulnerabilities was not gathered for future action, but for immediate judgment, a classification that has already been processed or is currently being processed at a location far beyond the reach of human influence. In this framework, the transmission event is not a prelude to a future mission, but the decisive element of one. The probe scanned Earth, evaluated Earth, transmitted their findings, and departed. The next phase is not another probe. It is not communication. It is not negotiation. It is not curiosity. The next phase is the conclusion reached by the intelligence that now holds the full profile of our world, and the Council, reviewing the exhaustive detail of the probe's scans, understood that Earth's fate is no longer determined internally but externally, based not on who we believe ourselves to be, but on how we were measured by devices more precise, more patient, and more advanced than any technology humanity has ever created. And so the scientists, now aware of the scale of what their instruments detected too late, were forced to confront an idea that none of them wished to speak aloud. Once a planet is evaluated, once its defenses are mapped, once its vulnerabilities known, the decision that follows is no longer shaped by the planet's intentions, but by the intentions of the one who requested the evaluation. And Earth, for the first time in its history, is no longer the observer but the observed, no longer the analyzer but the analyzed, no longer the one who studies the heavens, but the one whose position in the cosmos has been quantified and reported. Whatever comes next lies beyond the reach of human science, but not beyond the influence of the data that Atlas and Sven carried away, data that now defines us in the eyes of a distant, unknowable intelligence. When the Scientific Council progressed from modelling possible consequences to examining what a follow-up contact event might look like, the atmosphere in the room shifted from analytical unease to a deeper, more suffocating dread. Because for the first time they were forced to imagine Earth not as an isolated world but as a node in a larger cosmic network, a world whose profile had already been transmitted, catalogued and possibly weighed against criteria we do not understand. The Council began by examining the structure of the probe's data one final time: the layered compression, the distribution of electromagnetic sampling, the granularity of atmospheric scans and the depth of the magnetospheric modelling. These were not the metrics of idle curiosity. They were the metrics used to determine not only what Earth is, but how Earth would behave under intrusion, interference, or controlled observation. When analysts mapped these metrics onto hypothetical contact frameworks, extrapolated from human logic, military logic, and machine logic, the resulting picture was not one of peaceful curiosity or tentative outreach. It was a sequence of operational possibilities, each more sobering than the last. The first possibility, considered the most conservative, is that any intelligence receiving the probe's data may deploy a second generation of reconnaissance devices, not to repeat the same survey, but to test specific boundaries identified as weaknesses in the first report. Such probes would not mimic the passive, silent behaviour of Atlas and Sven. They would insert themselves into orbital shadows, space weather anomalies or blind arcs where Earth's monitoring systems have been historically weakest, observing whether humanity responds more effectively now that the existence of external observation is known. This scenario suggests a probing intelligence not interested in communication, but in verification checking whether the subject has grown alert or remains vulnerable. The second possibility, far more complex, imagines a type of contact that is not physical at all but informational. If the receiving intelligence operates on principles of strategic caution, it might choose to test Earth's internal thresholds through indirect means by inducing anomalies in electromagnetic fields, modifying solar interaction zones, or generating faint artificial signatures that mimic natural cosmic phenomena, yet carry subtle patterns designed to provoke analysis. Such a contact would be a test of comprehension. Can Earth recognize a manufactured anomaly, identify its source, or interpret a pattern not shaped by natural physics? This form of contact would not require any spacecraft at all. It would require only knowledge of our vulnerabilities and the ability to exploit them from afar. The third possibility, and the one that caused the longest silence in the Council, posits that the probe's data may trigger a form of contact structured entirely through the lens of strategic evaluation. In this framework, the intelligence at the receiving end does not approach Earth as an equal or a curiosity, but as a potential variable in a broader calculus. If Earth was classified as non-threatening, incapable of space-based defense and lacking both offensive capability and real-time cosmic awareness, as the probe's data suggests, then the resulting contact might not be a dialogue, but an operational phase whose nature depends on the external intelligence's objectives. Such objectives might include resource assessment, environmental manipulation, long-term monitoring, or even controlled intervention. None of these require communication, none require consent, and none require a presence visible to the human eye. The probe's data in this scenario would be used not to inform a conversation, but to calibrate an approach. The intelligence would know where Earth is blind, where its magnetic shield is fragile, where its satellite networks are overextended, where atmospheric patterns are most easily disrupted, and how slowly humans interpret deviations from the expected. The transparency of our vulnerabilities, laid bare by Atlas and Sven, would become the foundation for any strategic decision they make. Yet the fourth possibility, which the Council admitted with the greatest reluctance, is the one most consistent with the cold efficiency of the probe's mission. In this scenario, Atlas and Sven were not precursors to contact, they were the contact. Their purpose was to evaluate whether Earth qualifies for communication at all. Their method was to assess whether the planet possesses the technological maturity, defensive stability, and cognitive awareness required for an encounter. The probe's silent departure and outward-bound transmission suggest that Earth's profile has already been categorized. If the intelligence that sent them operates within a hierarchy of planetary classifications, then we may have already been placed into a category that dictates the nature of future interaction, whether passive observation, cautious distance, or something more assertive. In this model, the next stage does not involve new probes or direct signals. It involves a decision made elsewhere, based solely on the data collected. And the terrifying implication is that we may never know when that decision is enacted, because the intelligence that deployed Atlas and Sven may not communicate in the ways we understand, may not appear when expected, and may not recognize the concept of contact as something requiring mutual awareness. To them, contact may be the simple act of evaluating a world and determining its relevance. And in the final reckoning, as the analysts stared at the reconstructed mission timeline, they understood that humanity is now living in the quiet space between phases, between observation and whatever comes next. The probes have left, but the consequences of their evaluation have not. Somewhere beyond our reach, the intelligence that sent them is processing the full portrait of Earth, its defenses, its vulnerabilities, its speed of reaction, its technological footprint, its environmental stability, its orbital chaos, its electromagnetic signature, and its behavioral patterns under the faint pressure of being watched. And for the first time in human history, the next step in this sequence does not depend on us, but on them, an intelligence we cannot see, cannot predict, and cannot negotiate with, because the only message Earth ever sent was unintentional, encoded in its fields, its noise, its weaknesses, and its silence. Atlas and Sven delivered that message perfectly. As the Council shifted its focus from hypothetical contact scenarios to the implications of the probe's data being actively processed elsewhere, the nature of their discussions took on an entirely new dimension, because the more they examined the structure of the information Atlas and Sven transmitted, the more clearly they saw that the data was not merely observational, it was simulation-ready. The atmospheric profiles, the magnetospheric stress curves, the electromagnetic response patterns, the orbital debris distribution, the technological signal leakage, the reactive timing of human monitoring systems, all of it had the granularity required not just to study Earth, but to model Earth. This realization forced the Council to confront a possibility far more alarming than the arrival of a second probe or a distant act of observation. The intelligence receiving the data may already be constructing scenarios, simulations, or predictive frameworks designed to test how Earth would behave under a variety of controlled conditions. To them, we are no longer an unknown world. We are a fully mapped system whose defensive and technological characteristics can be replicated, manipulated, and analysed without ever approaching our orbit again. And once a world can be modelled, it can be predicted. Once predicted, it can be influenced. Once influenced, it can be controlled, not through direct presence, but through the exploitation of its inherent weaknesses. The scientists were forced to admit that this form of indirect pre-contact modelling is not only plausible, but likely, given the structured nature of the probe's transmissions. The data contained enough information to construct a complete virtual model of Earth's magnetosphere, one that could be tested against artificially induced disturbances to evaluate how our protective layers collapse under pressure. Likewise, the atmospheric signatures gathered by the probes are detailed enough to model the chemical dynamics of our climate, including how pollutants, greenhouse gases, thermal gradients, and ionospheric densities respond to external energy inputs. In human terms, such data is the foundation for large-scale engineering simulations. In the hands of a more advanced intelligence, it is the blueprint for understanding how to manipulate a planet's environment without ever touching its surface. The probe's recordings of Earth's radio traffic, thermal emissions, and defense network patterns provide the additional framework needed to model how humanity reacts to anomalies, how quickly governments respond to disruptions, how effectively satellites compensate for signal loss, how rapidly scientists detect irregularities, and how predictably our global communication grid recovers from shock. This is not simply the study of a planet, it is the study of a civilization's reflexes. The Council's cryptographers then pointed out an even more disturbing possibility. Given the complexity of the encoded signals, the intelligence at the receiving end could be running iterative simulations of Earth in real time, evaluating multiple hypothetical futures simultaneously. They could test scenarios humanity has not even conceived of, measuring outcomes based on thresholds we do not understand. They could simulate solar storms amplified beyond natural ranges to determine whether Earth's magnetic field collapses or adapts. They could simulate artificial interventions, precise, targeted, subtle, to see how long it takes before humanity recognizes a pattern. They could simulate technological disruption of satellites, probing our resilience to communication failure. They could simulate atmospheric alteration, not to enact it, but to evaluate the consequences. And they could run these simulations millions of times faster than any biological civilization could ever hope to analyze them. In such a scenario, Earth is no longer a distant world waiting to be visited. It is a data set being interrogated for outcomes, a test subject in a computational experiment whose parameters we cannot perceive. When the analysts finally organized these implications into a coherent model, the room fell silent. Not out of fear, but out of the cold certainty that the probe's mission had already moved into a phase beyond human influence. If an advanced intelligence is modelling Earth based on the data collected by Atlas and Sven, then the next stage does not require contact, or communication, or arrival. The next stage is decision-making based on simulation results, decisions shaped not by our intentions, but by our predicted behaviours, our vulnerabilities, and our systemic weaknesses. And once those decisions are made, the mode of interaction, if any interaction occurs at all, will not be dictated by what Earth wants, but by what that intelligence determines is strategically optimal. This could mean decades of silent observation, or sudden intervention, or no action at all. But whichever outcome is selected, it will be based not on who we are, but on who we are in the model, a model constructed from data we did not consent to give and did not even realize we were transmitting. Thus the Council reached its most sobering conclusion yet. Earth is no longer an isolated world making its own predictions about the universe. It is a predicted world, its behavior pre-modeled, its responses pre-calculated, its vulnerabilities pre-mapped. And as the scientists contemplated this role, reversal humanity no longer predicting but being predicted, they understood that the greatest shift in the history of our species has already occurred quietly, unnoticed, without alarms or announcements. Somewhere far beyond our reach, an intelligence we do not understand now holds a complete, functional representation of Earth, and whatever comes next will be shaped by what that representation tells them, not by what we believe ourselves to be. When the Scientific Council finally turned its attention to the question of classification, the atmosphere in the room thickened with a weight that no mathematical model or signal analysis could disperse, because the moment they acknowledged that any advanced intelligence receiving the probe's transmissions might operate within a structured hierarchy of planetary types, they were forced to confront an even more unsettling reality. Earth's fate may already have been determined according to criteria we neither understand nor influence. In attempting to reconstruct what those criteria might be, the analysts began with the data categories the probes prioritized most: the resilience of Earth's protective layers, the density and coherence of orbital infrastructure, the consistency of electromagnetic emissions, the rate at which humanity detects anomalies, the fragmentation level of global communication networks, and the stability of our technological systems under environmental stress. These were not merely scientific observations, they were diagnostic indicators, the sort of metrics a distant intelligence would use to determine whether Earth qualifies as a world that can defend itself, communicate coherently, maintain structural stability, or sustain a controlled external presence. And the horrifying implication was that every one of these categories is measurable, quantifiable, and testable, and the probes performed those tests with a precision that makes Earth's vulnerabilities impossible to hide. The analysts then attempted to arrange these metrics according to plausible tiers of classification, extrapolating from humanity's own logic in evaluating unknown planetary bodies. If Earth were evaluated according to defensive capability, the probe's data would show a magnetosphere strong enough to deflect most solar radiation, but vulnerable to targeted high-energy disturbances. If the evaluation centered on technological maturity, Earth would appear developed enough to generate extensive electromagnetic noise, but insufficiently advanced to maintain coherent defensive or deep space detection networks. If the criteria involved environmental stability, the probe's scans would reveal a climate in flux, a biosphere stressed by rapid industrialization, and an atmosphere whose chemical signature reflects both life and technological strain. In any tiered system of classification, these findings paint a picture of a world in transition, neither primitive nor stable, neither advanced nor capable, neither defenseless nor truly prepared. It is the type of world that would trigger cautious interest from a distant intelligence, not for cooperation or conflict, but for understanding its trajectory. Is Earth a developing civilization on the brink of maturity, or a volatile and unpredictable world whose instability could pose risk or opportunity to an external observer? What struck the analysts hardest was that the probe's repeated evaluation of Earth's response time suggests that our alertness, our ability to recognize, interpret and respond to anomalies, may have been one of the most important factors in their assessment. Every maneuver that exploited our detection blind spots, every anomaly calibrated to test our sensors, every shift in the probe's scanning tempo aligned with the goal of measuring Earth's awareness. And the results, reconstructed from our own logs, reveal a sobering truth. Our global systems are inconsistent, fragmented and slow to react. Military sensors detected certain anomalies with precision, but failed to interpret their meaning. Civilian observatories recorded deviations that were dismissed as instrumentation artifacts. Space agencies documented irregularities that were never categorized correctly. To an external intelligence evaluating Earth's capability to detect or resist external influence, this inconsistency would be unmistakable. It would demonstrate that while humans possess sophisticated technology, we lack the unified coordination and rapid response structure of a civilization capable of defending its planetary environment. This conclusion led the Council to the final, most chilling classification scenario. Earth may have been categorized not by what it has achieved, but by what it has not yet become. In this scenario, the probes evaluated Earth as a planet with intermediate technological ability, but insufficient resilience to withstand hostile influence, lacking unified planetary defense, rarely attentive to its own orbital surroundings, and largely unaware of the vulnerabilities embedded in its electromagnetic and atmospheric systems. Such a classification would place Earth in a category that, by human analogy, would be treated as a world to be monitored, studied, and possibly shaped according to external priorities, rather than internal autonomy. And the worst part is that we would never know when that classification was finalized. It would have occurred the moment Atlas and Sven completed their transmissions, long before our scientists pieced together the meaning behind their movements. The Council's final conclusion was not expressed emotionally nor dramatically, nor with any attempt to soften the implications. It was stated with the cold, unadorned clarity of a scientific truth too large to escape. If Earth has been classified according to the data gathered by Atlas and Sven, then we are no longer only a world with its own trajectory. We are now an entry in someone else's system, a data point in a structure we cannot access, a profile stored somewhere in deep space waiting to be acted upon. Whatever decision follows will not be based on what Earth hopes to be, but on what it has already been measured to be. As the Council advanced toward the final and inevitably darkest phase of their investigation, the discussion shifted from classification to anticipation, because once they accepted the likelihood that Earth had already been categorized based on the data transmitted by Atlas and Sven, they were forced to confront the question that had been quietly accumulating pressure since the moment the first coded signal was detected. What form could a response take from an intelligence capable of deploying probes that perform such elaborate multi-layered reconnaissance without ever revealing themselves directly? The analysts began by cataloguing every metric in the probe's transmissions that related not simply to environmental conditions but to actionable strategic data magnetospheric elasticity, atmospheric tolerance to perturbation, electromagnetic noise density, orbital instability, radio pattern coherence, technological clustering, response lag, and thermal distribution across populated regions. Every one of these elements represents a variable that can be exploited, tested, or influenced remotely, and together they form a structural map of Earth, not as a planet, but as a system whose behavior under stress can be predicted with disturbing accuracy. The Council realized that if an external intelligence is sophisticated enough to send reconnaissance devices across interstellar distances, then it is sophisticated enough to use the data from those devices to model potential actions long before undertaking them physically. And the more they examined this possibility, the clearer it became that the next phase, whatever form it might take, would not arrive in the shape of a sudden appearance or dramatic declaration, but as a series of subtle, controlled, precisely calibrated steps designed to validate the conclusions drawn from the probe's report. The analysts proposed the first category of potential responses as validation events, small-scale intrusions or anomalies engineered to confirm the accuracy of their simulations. These events could take many forms: slight unpatterned disturbances in Earth's magnetic field that mimic natural fluctuations yet contain structural qualities only visible through deep analysis. Carefully timed interference with satellite communication that appears to stem from space weather anomalies, yet repeats with a frequency inconsistent with solar activity. Unexplained fluctuations in atmospheric ionization that correlate with simulation stress tests, or faint artificial spectral signatures that appear in ranges normally treated as cosmic background noise. Such events would not be designed to harm Earth or to communicate with it, but to test whether humanity is able to identify, interpret and respond to controlled, subtle deviations. If Earth fails to notice them, or notices but cannot correctly categorize them, then the intelligence would gain confirmation that its simulation of humanity's awareness is accurate, reinforcing the classification already assigned. The second category of possible responses, far more complex and disturbing, involves what the Council termed strategic influence operations, in which the intelligence might attempt to manipulate Earth's environment indirectly, observing how the planet adapts under artificially induced stress. This could involve altering the frequency of natural cosmic phenomena, such as amplifying solar wind variability through still unknown methods, or creating resonance shifts within Earth's ionosphere to nudge weather patterns toward extremes that reveal structural weaknesses in global infrastructure. It might involve producing electromagnetic anomalies that disrupt GPS, communication networks, or early warning systems not destructively but diagnostically, as a means to determine how long it takes humanity to re-establish coherence, whether nations collaborate under stress or retreat into isolation, and whether our civilization possesses the resilience to survive controlled tests without collapsing. The terrifying element of this scenario is that such influences would appear natural to most observers. The intelligence would have no need to reveal itself or take responsibility. Earth would interpret the disturbances as environmental instability, while in reality, they would be responses to the probe's evaluation, carried out by an unseen hand. But the Council's deepest concern, and the one that cast the heaviest silence over the room, was the possibility that the intelligence has no intention of directly influencing Earth at all. Not because it lacks the capability, but because it does not need to. In this scenario, Earth's classification determines the next step automatically. If we are deemed harmless, inconsequential, or strategically unimportant, the response may be permanent non-engagement, a form of cosmic quarantine, where Earth remains observed but never contacted, allowed to evolve without interference because it poses neither risk nor interest. If we are deemed unstable or unpredictable, the intelligence may choose to monitor Earth from afar indefinitely, waiting for signs of development, collapse, or transition. But if we are classified as potentially problematic, capable of future expansion, yet currently defenseless, the intelligence may adopt long-term containment strategies, ensuring Earth never reaches a stage where interaction becomes dangerous or unpredictable. This would not require ships, weapons, or visible presence. It would require only the persistent awareness of our limitations and the ability to subtly discourage any trajectory that might elevate Earth's strategic significance. And when the analysts step back from their models, they realize that all three scenarios' validation events, strategic influence, and long-term containment share a single chilling characteristic. None of them require Earth to be aware that it is responding to external agency. The intelligence, armed with a complete and detailed model of our world, would never need to contact humanity in the traditional sense. It would act through silence, through physics, through carefully tuned anomalies and strategic invisibility. The probes were not precursors to dialogue, they were precursors to understanding how to act without ever being seen, and the Council, faced with this possibility, understood that the greatest danger to Earth may not be an invasion, a message, or a visible arrival. The greatest danger may be a future shaped by an unseen intelligence that already knows everything it needs to know about us. As the final phase of analysis unfolded and the Council synthesized every strand of evidence, from the reconnaissance protocols embedded in Atlas and Sven's flight paths to the layered complexity of their outbound transmissions, one conclusion began to overshadow all others, a conclusion so immense and so destabilizing that even the most methodical minds hesitated to articulate it fully. The next stage of this sequence may already be underway, not through the arrival of new probes or visible manifestations in the sky, but through the silent remote influence of an intelligence that now holds a complete and model-ready portrait of Earth. The weight of this realization bore down with increasing force as researchers confronted the implications of a world whose future trajectory may be shaped not internally, but externally, through decisions made by an entity whose logic, intentions and frameworks lie far beyond human comprehension. The question shifted from will they respond to how would we even recognize a response if it were happening? And this question, once considered fringe speculation, became the core of the Council's final discussions, because if a civilization is advanced enough to send recon probes across interstellar space, gather multi-layered assessments of a planet's defenses, and return that data with surgical precision, then it is also advanced enough to influence that planet indirectly through astronomical, electromagnetic or environmental means without any identifiable signature of intervention. And the more the Council examined this possibility, the clearer it became that Earth's vulnerability lies not in what an external intelligence might do to us, but in what it can do without us ever realizing it is happening. The scientists began by outlining the form such remote influence could take, drawing from humanity's own technological strategies, while acknowledging that a civilization capable of designing probes like Atlas and Sven would possess methods far beyond our reach. They noted that controlled manipulation of cosmic variables, subtle modulation of solar wind flux, small but precise alterations in magnetospheric resonance, engineering of ionospheric wave patterns, perturbations of high-altitude atmospheric chemistry, could produce global effects indistinguishable from natural variability. A shift in solar wind density, timed to coincide with a geomagnetic vulnerability already identified in the probe's data, could temporarily degrade Earth's communications without registering as unnatural. A minor alteration in ionospheric charge distribution could disrupt radar systems or GPS networks while appearing to be a routine anomaly. Even the frequency of meteor influxes could be subtly influenced by manipulating particle streams in interplanetary space, creating stress tests of Earth's orbital monitoring capabilities. To humanity, these events would look like coincidence. To an external intelligence, they would be the unfolding of a predetermined model. What unsettled the Council even more was the realization that influence need not be hostile or aggressive to be significant. It could be exploratory, observational, corrective, or even preventive. A remote intelligence might decide to steer Earth away from particular technological paths by subtly hindering their efficiency. It might test the robustness of our global infrastructure by introducing patterns of minor disruption. It might alter environmental variables to observe our adaptability. Or it might intervene only to stabilize Earth during moments of vulnerability, ensuring the planet remains within a trajectory beneficial to its own interests. Each of these scenarios is compatible with the data collected by the probes, because each one requires the same foundational ingredient: precise, simulation-ready knowledge of Earth's systems. The probes delivered that ingredient flawlessly. The Council then turned to the broader philosophical implications, recognizing that humanity has always perceived itself as the active observer of the universe, the species that watches the skies and seeks meaning in the unknown. But now, with Atlas and Sven's mission laid bare, Earth has become the observed. Every assumption that humanity holds about its place in the cosmos, its solitude, its safety, its autonomy, must now be reconsidered in the context of a universe where intelligence may not announce itself through visible arrival or communication, but through the meticulous evaluation of a world conducted before humanity even knew it was being tested. The idea that Earth's trajectory might now be the subject of external strategic consideration forced the Council to confront a psychological shift unprecedented in human history. The understanding that we are no longer invisible, no longer unmeasured, no longer operating solely within the boundaries of our own agency. Somewhere beyond the reach of our instruments, an intelligence is analysing a profile that defines Earth not according to cultural narratives or scientific hopes, but according to quantifiable, exploitable realities. The final conclusion reached by the Council was delivered not as a warning but as a statement of fact, grounded in observation and supported by every pattern uncovered in the probe's behaviour. The next phase will not begin with a signal, a ship or a visible event. It will begin with a change subtle, precise and perfectly aligned with the data Atlas and Sven carried home. Whether that change manifests as a shift in Earth's environment, a pattern in its electromagnetic fields, a disruption in its technological systems, or a silence deeper than any we have previously experienced, it will not reveal itself as contact. It will reveal itself as consequence. And in that consequence lies the stark truth the Council could no longer avoid. Earth is no longer merely a participant in the universe but a subject within it, and whatever follows will be determined not by what we choose to do, but by what has already been learned about us.